Good day to sir. I'm Corporal from Group 7. Today, my teammates and I are going to present our topic, which is implementation of a fully automated production line. Precision Dynamic Malaysia Sendirian Berhad is a company specializing in high precision component for the semiconductor and electronic industries. Although the company has experienced strong growth over the past few years, it is facing several challenges, including rising labor costs, difficulties in recruiting skilled operators, increasing competition, and higher customer expectations. To address these challenges and remain competitive, the company plans to implement a fully automated production line consisting of CNC machine cells, robotic handling system, automated optical inspection, and conveyor system. The initiative is expected to improve productivity, enhance product quality, and enable 24 hours operation and reduce reliance on manual labor. Now let us proceed to project overview. The objective of this project is to design, install, and commission a fully automated production line at the company's Penang facilities. The project duration is 14 months, starting from August 2026 until September 2027. The approved budget is 4.5 million, which includes a 10% contingency reserve for unexpected costs. The project scope covers all major phases from feasibility study and vendor selection to installation, integration, operator training, and production ramp-up. The project will be considered successfully if it is achieved at least 90% line availability, 98% first pass years, and payback period of 4 years or less. The project consists of 12 major activities. It begins with a feasibility study and requirements specification to evaluate technical and financial feasibility. Next, vendors are evaluated and selected before proceeding to detailed system design. The procurement and fabrication phase is the longest activities, taking 16 weeks because major requirements such as CNC machines, robots, and LI systems must be manufactured and tested. Feasibility preparation is conducted in parallel to shorten the overall schedule. After equipment delivery, installation and system integration are performed, followed by testing and commissioning. Operator training is conducted simultaneously to ensure workforce readiness. Finally, the project enters the pilot ramp-up stage before full production and project closure. That's all for project activities. Now I will pass my mic to Kelvin to explain implementation issues.
I am Kelvin. Thank you. Now that we have walked through our project activities and schedule, I would like to move on to part 3 of our analysis, the implementation issues. We are a 60-person firm and we are taking on a 4.5 million automation project using technology that is completely new to our organization. Because of that, before we could even build our risk register, we first have to be honest about the practical challenges of carrying out this project. We identified 6 key implementation issues and a clear strategy for each one. Let me take you across these 6 issues. The first is our limited capital and the pressure on return on investment. 4.5 million is a very large commitment for a company our size, and any cost overrun will put a direct strain on our cash flow. So we protect ourselves with milestone-based vendor payment, hire purchase financing for major equipment, government automation incentives, and earn value tracking so that we can catch any overrun early. The second issue is our in-house skill gap. Right now, we do not have any robotics or PLC engineers, which would leave us completely dependent on vendor. We close that gap with a 2-year vendor support and spare part contract by training 6 of our own technicians and by recruiting 2 more automation engineers before commissioning. The third issue is workforce displacement and morale. Moving away from manual labor creates anxiety, and we cannot afford to lose our experienced operators before the new line is established. Our answer is no retrenchment redeployment policy. We retain operators as line technicians and quality inspectors, supported with early and honest communication. The fourth issue is integration with our legacy system. The automated line has to exchange data with our existing ERP and run side by side with the manual line during this transition. We reduce the risk by locking the interface specification at design freeze, running simulation and factory acceptance testing, and then a stage side acceptance test with a parallel run. The fifth issue is our economic and supply chain exposure. Most of our equipment is imported from either Germany or Japan, which exposes us to currency movement, shipping delay, and semiconductor demand cycle. We manage this with fixed price ringgit contract where possible, currency hedging, schedule buffer, and a phased decision gate after a feasibility study. And the sixth issue is protecting quality and delivery during transition. Our customer expects zero disruption to quality or on-time delivery. So we keep the existing manual line running until the automated line proves that it can hold 98% of our production for 8 consecutive weeks. The key message here is this: every one of these 6 issues have a name owner and a concrete practical mitigation. That discipline is exactly what we feeds into a formal risk register that my teammate will present next. So with these implementations clearly mapped out, let me hand over to Jahan, who will walk you through how we rate and prioritize this as a formal project risk. Thank you.
Thank you, Kelvin and Jahan. To support the automated production line, our team selected retrofitting the existing Penang plant instead of building or renting a new facility. The existing site already has available space, utilities, and skilled support staff. This option can save approximately 2 million ringgit and shorten the implementation schedule by 4 to 6 months. For facility planning, a U-shaped automated cell layout was chosen to minimize material movement, improve workflow efficiency, and allow easier supervision of multiple stations. Next, besides location and layout, management decisions are critical to project success. The company will use a phased rollout strategy by implementing one automated line first before expanding further. Funding comes from internal resource, hire purchase financings, and government incentives. A steering committee will oversee the project and conduct monthly reviews to ensure cost, schedule, and scope remain under control. Finally, a project risk management plan is established to identify, assess, and control project risks. Risks are classified into 6 categories: technical, safety, financial, organizational, external, and operational. Each risk is evaluated using a probability and impact score, allowing the team to prioritize resource and mitigation effort effectively. The result value will be used to determine the risk threshold and necessary management response based on the following scale. With this risk management framework established, Nicholas will now present the risk register, which contains the specific risk, rating, and mitigation actions. That's all for me. Thank you.
So thank you, Jahan. My name is Nicholas Lindsay. So risk registers is used as a pre-planned backup to ensure the team has a plan B before crisis occur. So we use this to justify reserving contingency funds exclusively for the high trip risk. And we also use this to assign a specific owner to each trip for clear accountability and guide the management to focus immediate resource on catastrophic hazards. This is our implementation of risk register. So the first and the most critical risk is equipment delivery delay. It is about the importer CNC machine and robotic system may be delayed because of the vendor production backlogs, shipping disruption, or custom clearance issue. Since this risk has a probability of 4 and an impact of 4, he received an extreme rating of 16. Late delivery can postpone installation and commission activities by 1 to 2 months and may affect the customer order fulfillment. So to solve the problem, the contract's reputed damage clauses, which punish the vendor for late delivery, will be enforced by the procurement lead. The current manual line will continue to operate as a backup to fulfill customer order until the new equipment clear custom. So the risk is owned by procurement leader. So the second extreme risk is about the capital cost overrun. So depreciation of the Malaysian ringgit against Japanese yen or euro together with unexpected site preparation costs may increase the total project expenditure beyond the 4.5 million budget. Mitigation measure include the currency hedging, fixed price contracts in Malaysian ringgit, maintaining a 10% contingency reserve, and continuous cost tracking using earned value management. So the finance manager is the responsible for this risk. So the third extreme risk is the shortage of internal automation expertise. So without the adequate robotic and PLC knowledge, the company may struggle to operate and maintain the new automated system independently after the project handover. This can increase downtime, operating costs, and dependence on external suppliers. So to address this risk, 6 technicians will be trained and 2 automation engineers will be recruited and 2 years supplier support agreement will be secured. The risk is owned by the HR manager. So next, all these high-level risks has a rating of 12. The first high-level risk is the system integration failure. The new automated line may fail to communicate properly with the existing ERP system, so it may affect the production data, receipt, and traceability functions. So the impact of this issue could be commissioning delay of 2 to 4 weeks, lose the real-time monitoring benefits, and the mitigation that we implement include the software simulation, factory acceptance testing using the actual production data, and vendor integration support during the commissioning. So the automation leader manage this risk. So heavy equipment lifting, electrical installation work, and also the robot operation could result in injury or regulatory violation. Such incident may cause project delays, financial losses, and loss enforcement action. So we will conduct HIRARC, which is called HIRAC, assessment for all installation work. This assessment is about the hazard identification, risk assessment, and risk control. So beside that, we will install safety cutting and interlock and enforce lockout, tagout procedures before receiving the DOS certification. So the safety officer will be responsible for this risk. So next high risk will be the red out quality and yield loss. During the red out phase, the production yield may fall below the target of 98%. This could result from unoptimized process parameter and normal process variation. Consequences include increased report costs, delay customer qualification, and the postponement of all of full production release. So mitigation action include the process capability study, stress production ramp up, and daily yield monitoring with vendor support. So the risk will be managed by our quality assurance manager. Final high-level risk is about the workforce resistance to automation. Employers may fear job displacement, so this may result in low models, reduced cooperation from the employers, or resignation of experienced workers. So this can slow the knowledge transfer and disrupt training activity. To mitigate this risk, management will implement a no retrenchment policy, retrain employers for higher value technical roles, and actively involve workers during the system implementation. So the HR manager will on this risk. So last, our median risk has rating of 6 to 9. First median risk is unplanned downtime caused by the equipment breakdown or cybersecurity incident. So this may interrupt the production, delay delivery, and increase the maintenance costs. We will implement mitigation measures such as preventive maintenance schedules, spare parts inventory management, network segregation, firewall, and offline backup. So the automation leader is responsible for this risk. The second major risk is declining market demand caused by the economic recession or a slowdown in the semiconductor industry. So reduced demand may extend the project payback period and result in the underutilized production capacity. So to reduce this, the production line is designed to support multiple product families, providing a greater operational flexibility. So the risk will be managed by the managing director. The last major risk is the vendor lock-in or called vendor insolvency. Dependence on a single supplier may create difficulties obtaining technical support, software update, or spare parts in the future. The project may also face higher upgrade and maintenance costs. The mitigation measure that we do include selecting Office UX compatible system, avoiding proprietary technology where possible, and establishing source cost escrow agreements. So this risk is managed by the sales manager. So I will pass to Huilong to do a conclusion for our assignment. Thank you.
Before we end the presentation, let us proceed to conclusion. In conclusion, the automated production line will improve productivity, quality consistency, and operational efficiency. Through our risk management analysis, key risks and opportunities have been identified together with appropriate mitigation strategies. With proper implementation and continuous monitoring, this project can successfully achieve its objective and strengthen the company's competitiveness in the semiconductor industry. That's all for our presentation. Thank you.